Okay, so start with an apology. Obviously, I would like to present you in German, but that's coming in the next release. It's going to take me a little time to work out how to do that naturally. If I do speak too fast, then please just raise your hand if you want me to repeat something, because I tend to get excited on stage, so apologies in advance. I thought I'd talk to you today about Juniper's investment around cloud. I don't know, how often you get to listen to us talk about what we do in the area of cloud. We're very known for what we do down in the weeds of networking. But obviously, the network is a fundamental component part of what a cloud is. So it's actually my responsibility within Juniper across EMEA to really look at what our customers are trying to achieve, and what can Juniper do to support their business. So I have a business development function. What I will say is that no one cloud is the same, no one customer is the same, everyone's trying to do things differently. That's our industry, getting used to it really. But there are certain sort of trends that I think are important, so we'll start with that. I guess a cloud investment strategy sort of really takes place in many different areas. I mean, obviously the first thing that we try to look at is, from our end customers' perspective, how are they trying to get from where they are today to the cloud? And there's many different ways of doing it. The starting point would be the migration from applications they use in-house to actually making the decision to effectively go and use resources which are in some other cloud and migrate towards a SaaS model. So obviously, you get organizations where they're trying to minimize their IT spend themselves, close down legacy applications and effectively go and move to these new sort of applications which are not hosted locally. A lot of our customers are actually doing that actively, and I guess that's a very, very big industry trend right now. And many companies have started up in the SaaS world and making absolutely millions. Whether their revenues are that big isn't the point. The thing is, it's the place to be. With a SaaS model and subscription revenues, all that sort of stuff is what the industry wants to see, and where investors want to put their money. So lots of things happening around cloud migration. I'm going to spend quite a bit of time on that, so I'm going to come back to it. Obviously, the whole discussion around if you're going to build a cloud, is it in your premises, private, or do you want to use public resources? All those different topics. One other big area is this whole topic of microservices. So if you do have applications which are the revenue generation tools for your business, obviously the way that you communicate with your end customers now is much more digital than it ever used to be. My children don't know how to use the phone really to order anything. It's all done with my credit card online, and it's just it's the way of the world. But the key thing about the whole microservices aspect is the ability to really generate applications very, very fast, to get them in front of your end customer and effectively trial them for a period of time, and if they're not working, you fast fail and you move on. So the development cycle in that whole space is extremely important, and there's a set of tooling that actually the organizations need in order to effectively build applications. So we'll touch on that piece. I thought it's worth saying something about open source. Juniper traditionally has not open sourced all of our IPR, our intellectual property. So when it comes from where we came from in the world of networking, they were quite closed systems. Obviously, we sold to our customers based on the fact that we were better, faster, more efficient than anyone else. The industry's changed, and the expectation is that really to make massive progress in the industry, you have to effectively share. And obviously open sourcing is a good way of actually achieving that. There are pros and cons to an open sourcing model. We have a number of what I would call sort of virgin customers that effectively treated open source as being something free that they could pick up, they could use all the resources and then effectively go to market on. And that's absolutely fine for organizations that are completely sort of DevOps focused, have networking expertise, and they treat it as their main business. It's less okay for organizations that have taken that route, that have effectively struggle longer term to deal with the support aspect of it. And quite a lot of our original customers, a lot of the adopters that we had around some of our early products effectively came back and said, Juniper, can you actually support that piece? Because we effectively want to focus our efforts on other areas for their business. So it's one of those interesting topics for us. But we are totally committed to it. As you're probably aware, the Open Contrail project has been going for now 5 years or so, maybe slightly longer. We acquired that technology back in 2012, and it's gone from strength to strength. So we are remaining by the effort around trying to make a community work. And also, though, making sure that we can support our customers as they become very dependent on that technology. So that's the open source piece. There are other topics that we could cover. I mean, IoT is a big one. Certainly in the world of service providers, it's changing the way that clouds are built. So with huge amounts of devices, there are actually natural aggregation points where all this traffic needs to come to. And it's not always best to have huge amounts of devices feeding one centralized cloud. So we're having discussions with some of our service provider friends about how to actually distribute the cloud in certain areas geographically. And the main aim of doing that is really to make sure you minimize, there's latency discussions and a number of other things, but the aim of it really is to have some high power sort of cloud-based assets right at the edge. Natural collection points is where you want to do that. So lots of discussions around MEC technology, mobile edge computing, or I think it's now multi-access edge computing or something along those lines. We keep changing the name of what it is, but it's really around using sort of the benefits of cloud, but effectively spinning things up right at the edge of the environment. Machine learning and AI, obviously, very exciting topics these days. It is actually relevant even to Juniper, though, because we are actually investing in certain technologies and actually exposing them to our end user. So cloud is an extremely complex area. Certainly in the area of monitoring cloud estates, you absolutely need to have machine learning and AI. We have to invest in it, really to try and keep the cost down, minimize the complexity to the guys that have to operate these environments. So there's lots of investments going in that space. We're even looking at these natural language processing sort of environments. How about the cloud environment starts to talk to you to say when it's not feeling very well, that sort of stuff. There's all sorts of conceptual things that we're actually looking at the moment. So it's quite an interesting space, lots to be done. So let's just talk about the progression to the cloud. So I'm not going to sort of pick on any type of organization. Enterprises and service providers go to the cloud for their own reasons. There are three fundamental business reasons why you do it. One of them is just to deal with just the expansion of what cloud needs to do, so growth. Obviously, from an enterprise perspective, the more customers you can attract to you, if you do that mostly in a digital commerce way, you need to be able to expand and grow rapidly, and a cloud will enable you to do that. For a service provider, the whole Internet of Things is another reason why they need to rapidly grow in different areas geographically. Probably most people talk about agility, and that's really sort of one of the main reasons of moving away from traditional data center architectures and moving to a cloud infrastructure. How do you spin things up, test it, prove it in the market, and then effectively, obviously, make big money from it, hopefully, and if not, just move on, do the next thing. So that's obviously a topic when we're really speaking to the execs in organizations. What is it they're trying to achieve from a business perspective, what they do today and where they want to be tomorrow. The cloud investment is a fundamental part and reason behind really the where these businesses want to end up. What is a general common theme though is that no one's getting more money. Most budgets are flat. They're not growing. In fact, in a lot of cases, they're actually shrinking. So another aspect around cloud is how actually can it help? If it makes the world more expensive, more complex, really it's defeating the whole object of what we're trying to achieve. So hopefully you guys are all familiar with that anyway. What it really comes down to, though, in terms of sort of four big areas of investment, and certainly from a Juniper technology perspective, this is where we're spending our time and effort. So we now talk to DevOps teams. Traditionally, Juniper would never speak to a DevOps team, didn't know who they are. We really had nothing to do with applications. We just provided the plumbing to connect everything together and just went, there you go, we'll do it as fast as possible at the right cost point. That's not the case anymore. I have to actively go and find out who in the organizations we've spoken to years are actually doing DevOps, which is it's an exciting role. I get to meet new people. But the reason for it is because in the world of DevOps, what you actually need to do is provide tooling that enable the dev team to set up environments where they can quickly build something and then throw it away. And you can't do that without actually understanding the networking parameters at the same time. So depending on where you want to spin up an environment, you actually suddenly need a bit of networking, a bit of compute, a bit of storage. You then might need to migrate that whole environment into a sort of test and staging environment, and then into production, and all of that requires automation. So some of the areas that Juniper's invested in is really around sort of trying to help those DevOps teams go through that cycle. Gone are the days of building labs and spending weeks of trying to do up the initial setup and configuration. These environments need to be spun up in minutes and available. Get the job done, move on to the next thing. So lots of work there. in the conference today, the topic of infrastructure as code has been, has come up multiple times, and that's another very important point. So the networking has to be as agile and flexible as compute and storage is. We are playing catch up, is the honest truth from an industry perspective, but I think we're sort of pretty much there from the technology that's now called it's called SDN. We've really given the ability to drive the networking constructs via APIs and also modeling constructs. So it's obviously a very important point. I didn't want to dwell on that too much because I know there's been other topics on that today. One area that I am going to spend a bit of time is around the poor old ops guys, because I spent quite a lot of time with customers in the sort of area of going through labs, and then you get to the point where you sort of get on a project where it actually hits the operations team, and quite often they get brought into it very late. And we've actually seen from an OpenStack perspective, the adoption in certain customers has been completely slowed down because the investment with the operations team wasn't put in early enough, especially the infrastructure team, the guys that will be up all night if something goes wrong. The reason for that is because it's highly complicated. We made the work more complicated for them, and they haven't got the tooling to actually really sort of quickly adapt to what's actually happening in infrastructure as these cloud estates grow. So I'm going to spend some time on that because there's a big investment from Juniper around that area. This whole topic of COTS platforms versus custom ASICs is a conversation that I often get sucked into. Coming from Juniper, it's not surprising. The reality of it is this is all about the business case. Even we choose to actually take on COTS hardware where it makes sense, especially where it's becoming a standardized application. It gets to the point where you're fighting for pennies, really to sell hardware. And to be honest with you, that's not a good long-term business model. So we actually, look at where we're going to develop custom chips for, a lot of more specialized, potentially high-end use cases. And then where it comes down to sort of high volume, very, very standard based sort of use cases where the hardware needs to just look and feel the same, then effectively we will actually even look at bringing on COTS model. The important thing about it is about disaggregation of the software from the hardware. So a lot of the investments internally to do that are based on, traditionally everything would have been packaged as one hardware software bundle. What you actually have to do is break away the way that you communicate with the actual hardware components and effectively separate the software with layers, and that's a lot of the internal investments that we actually do. So we do have the choices of, can we deploy this on x86, can we deploy it on someone else's equipment, and obviously some of our big service providers mandate to us the hardware, and we just say, okay, here's the software that gives you the value that you're really after. So loads of investment around all those different topics. When it comes to this, the barrier, the drivers and barriers, I've spoken about the barrier. I think we all know the drivers behind cloud, so I won't dwell on that. This whole topic around operations is a thing that has really hurt, I would say, us as a community in the last couple of years. In OpenStack, I think we're getting better. It's definitely something that, if you look at sort of what was said in 2015, I think we've actually moved our way down now to actually address some of the issues. And you certainly don't believe that anybody. I think I can quite stand up and speak around the fact that we've hardened the technology. The OpenStack community has, certainly from an SDN perspective, we and many others have got very, very strong deployments in production of SDN technology. So the technology maturity problem, I don't think is so much there anymore. It is much more about how do you actually take a concept from a lab and actually put it into a production environment and really deal with the operational problems. And that's something that we still continue to work on. And I'll give you an insight to Juniper strategy in that area. Enterprises are going through massive disruption at the moment. If I look at my daily life, I spend half my time on the road, probably a quarter of my time in the office, and then the rest of the time working from home. I can't think of any time at the moment in the last year or so that I've actually used an internal Juniper application. So we've already gone through the transition of effectively our, obviously email went ages ago. Our entire communication mechanism across the organisation has moved to things like Link. We do SharePoint sharing. We use Dropbox. We've already effectively done the SaaS thing. We didn't want to invest our time and effort on those parts of technology. It's not our core business. Someone else can make money out of that. We'd rather just consume it and keep our actual cost low. So we've already gone through this transition that many other organisations haven't yet got to, but they're starting to. So it is a big shift. From a development perspective, we've even with everything we sell, we've gone from quite large monolithic applications that we sell to the market to actually breaking them up into microservices. We're becoming more and more containerized with everything we do. You'll see, as part of our security portfolio has gone through the sort of the hardware to the virtual machine based to the actual container-based technology now. So we're doing it all the time. We're going through that sort of continuous churn, but doing it for the right business reasons. Obviously, when it comes to container technology and microservices, it's really about portability. It's about how do you scale, and how can you actually flexibly deploy different component parts across different clouds. So it gives you the ability to really be highly flexible on what you want to do. Again, the key thing though is even for our own developers, actually having a PaaS environment, an infrastructure which they can develop on, throw it away, create a new one is very, very important. So most of the things that we see in the industry are things that we actually have struggled with ourselves anyway. Just on the last point, so there is also a team that's really responsible for where applications get deployed. Do you make conscious decisions around deploying something in a private cloud environment? There are security regulation reasons why you might want to do that, but a lot of companies are saying actually we'd like to deploy first a public cloud style approach, and then sort of just minimize what we do in-house. So it really depends on what it is you do as an organization, but lots of decisions. And there's actually tooling required around actually understanding where to place workloads, which is something else that we've got to help these organizations get right. I'm hoping that one day I can get rid of this chart. The problem is I still see today, as Juniper, we still have customers that build networks and have a network team that don't talk to the DevOps guys. I can't believe it, honestly, I can't, but we still have it today. I'm not going to name names, but it's rather frustrating for me because I'm trying desperately to get, to talk to organizations that are trying to get to cloud about making the networking team part of the whole DevOps organization. Really understand the IT guys, and to be honest with you, I come from a networking background. I've been doing it for 20-some years. I know full well that for my own career, I want to be able to talk IT stuff. I need to, and I really think that the networking teams need to be part of this, need to be brought in. But I'm still seeing a lot of resistance to it. So it's something that I'm just hoping that over time, that problem will go away. The reality is that if you build a fantastic network infrastructure, and you separate the NetOps team from the guys that actually run the IT side of the organization, you don't actually have cloud, not in its true form. So trying to see how, I guess the industry will jump over that hurdle and get those organizational barriers out of the way. In a lot of cases, it really is organizational and just controlling that actually stops it happening. So what is actually required for cloud then? So there is definitely focusing our efforts around the DevOps team and the tooling they need is absolutely one piece. There is actually another part of the ops organization that run the infrastructure though, and we mustn't ignore those guys because they're the ones that really are, they're the one that will be up all night if there's a fundamental either hardware problem or just general infrastructure problem, and that's bringing down the applications that support the business. So they are slightly separate roles. DevOps teams tend to create applications, they support the applications, but when something goes wrong, they throw it to the guys that go, this is your problem in the cloud, go fix it. Right? So you've got to understand that. The one thing I'll say that's quite important and a big shift for Juniper is that we had to stop selling to sort of the guys that operate the network and actually sell some of our solutions to these DevOps guys. So specifically when we talk about SDN, we're actually giving the DevOps, the IT community, the ability to drive the network. And that didn't really happen before the world of SDN. So this whole topic of infrastructure as code is an important thing. It's about if you want to deploy an application pattern, you deploy it in different modular component parts, and obviously that requires some compute, some storage. It requires absolutely networking segmentation and a number of other sort of attributes around how you want the network to be set up to support that deployment. And it also really has to include the policies that get built in the infrastructure to enable just the right amount of traffic to be passing through the different component parts and obviously stop everything else that shouldn't be there. So that's really been a big shift for us. Obviously, I guess you guys hopefully are aware of Open Contra and what it is. I'm not doing a product pitch on that today. It's not appropriate. But it really is around that sort of overlay networking layer to actually enable you to spin up networking services over the top of an existing network infrastructure. The aim is not to touch the bottom layer of the networking. It should do what it's good at, which is shipping packets around between different parts, different connectivity points. And really, all we really require from an overlay technology is that there's IP networking underneath. So it's giving you a layer of separation. So really, the SDN component is much more focused around sort of putting it in the hands of the IT community, which is an interesting change. But that said, and with that, obviously, a lot of other features and functions need to be sort of built in that just to make the networking piece simple and easy for an IT community to consume. The bit that I think we probably, certainly even Juniper, and I think actually most people in the industry have sort of not ignored, but just left, was what do you need to do to actually integrate the monitoring from an application perspective around the analytics? How does that relate to what's going on in the networking as well as the compute and storage? And also giving the tools to these guys, these poor guys at the bottom that effectively have to stuff has been going on all the time in this world of automation, and they're expected to turn up and understand what's broken. So the tooling to support that type of ops team is really important and something that we've really started to spend sort of time and effort thinking through. So building a network is, we've been doing that for years. Providing tools around how you model, how you suddenly want to instantiate a whole lot of new hardware is something that we can talk to you for days on if you really want to. But really dealing with this sort of how do you deal with monitoring in a cloud estate? Bearing in mind there are so many metrics. That's the key thing about cloud is you've got compute, you've got storage, and you've got networking. All of them are all creating metrics, things that you should actually be aware of. You can't look at them manually; it's impossible. So what is the right framework to actually help that team sort of understand when something's wrong, and that's really what I want to talk about in a minute. When you get to hybrid cloud, you're actually adding another layer of complexity because not only are you sort of spinning up components inside one cloud, you're actually spinning up components in another cloud, which potentially is a public cloud environment, and they have to talk to each other. So what you actually need to do in that scenario is make sure that the way that we create networking constructs in a private environment is identical to how you do it in a public environment. You don't want to make it look different because that's more complexity. The other thing you've got to do is actually how do you even get connectivity from your private environment? How do you connect it to your public environment? And that's also, today has been traditionally quite hard work with the manual mechanisms you need to set up the encryption tunnels and all that sort of stuff. So that's another layer of automation that is really important that we fix from an industry perspective, and actually spinning up gateways, spinning up firewall functions, all that sort of stuff, and actually doing it in public cloud environments based on what is effectively sort of a modelled metadata view of what you want this application to look like. So obviously you've got the whole topic of VPCs being spun up, and then how do you get connectivity, safe connectivity back to your private environments. So a lot of that all has to be automated. And it's something that our customers are looking at. They're either trying to do it themselves or they're coming to Juniper or others to say, can you actually help with just making this easy? Because it's currently a bit hard. So these are all sort of use cases that we talk about most days, to be honest with you now, around really trying to understand how they want to deploy things, how public cloud are our customers going, and then how effectively do they want, what's the rules around setting up connectivity between different cloud estates. So we're calling this sort of term cloud connector. But you can whatever name you want to call it, but it's effectively that how do you suddenly provision tunnels across actually the internet is actually something that needs a lot of thought. So a little bit then, just narrowing a little bit more out Juniper. I'm trying desperately not to make this a product pitch. I'll do my best not to. But this is about areas of investment. So I think connectivity, you guys would be pretty familiar with what we try to do. There's a whole lot of use cases around the branch office. There's a whole set of topics around SD-WAN, which is effectively around steering traffic either across dedicated VPNs or effectively building traffic streams across the internet and encrypting it, all that sort of stuff. Lots of excitement going on in that area. There's the whole sort of what's happening inside the data centers themselves and how to actually just construct sort of a application components, separate the network pieces, and all the tools you need to do that. Obviously, lots of stuff going on in the telco world, which won't surprise you, and everything that we're doing in Azure, Amazon, and Google examples. For one example in that space is we actually are placing our technology into their marketplace. So you can buy Juniper, routing and firewalling technology via Amazon, and just recently Azure. one of the reasons for doing that is because if you want to spin up, have gateways that spin up in your VPC, you effectively need to have licenses and stuff like that. So you can just basically go and acquire the right licensing and do all that from a cloud perspective. So the whole thing is really about automation. And then we get to this big world of Internet of Things, which I think I'll pass on. So these are the big investment themes I just wanted to talk about. The software-defined networking piece with our sort of open contrail technology, most of it is really inside the data center is about segmentation. The term everyone tends to use these days is micro-segmentation, but it's also about security policy enforcement. So, can this particular host that's supporting an application, is it allowed for these traffic profiles to effectively talk to this other host, all that sort of stuff. You define the rules and nothing else is allowed. Completely different to how we used to do networking. We used to have everything open and then we effectively used to firewall it all up. And that's obviously from an industry perspective is frowned upon these days. So that whole use case is around virtualizing the network and actually having policy that's inbuilt as you actually create those network constructs is really what we're doing. Lots of interesting discussions with mostly service providers around VNFs. They are virtualizing their core infrastructure. So they're doing it in the mobile world. They're doing it, from a VPN perspective. There's a whole loads of different use cases around how they used to do something by effectively cabling up different component parts of hardware, and now they're effectively saying we're actually going to spin up these virtual functions that do the same thing. And what they're asking us to do is how do they get the connectivity between those functions in a software world, and it's really about traffic steering through VNFs, and that's obviously the role of what SDN plays in that use case. We then get all of these different sort of, I call them multi-cloud orchestrations. So obviously we've spent a lot of time and effort with the OpenStack community. Glad you're all here. There's a lot of excitement around container technology, Kubernetes. We also, we are all aware of the dominance of some of our partners, such as VMware. The reality is of all this is that our customers should be allowed to pick and choose the environment they want to deploy. Our role, certainly from the team that I work in, is to try to make sure we have an offering which is, if you take one choice now, you can move to another and you still end up with the same networking overlay infrastructure. So your API calls don't change. You fundamentally can make under the cover changes without really adjusting too much the way that your orchestration systems work. That's part of the cost reduction that we're trying to help our customers with. Pick and choose and move on. Okay, so then we get to this whole world of what we're calling software-defined operations, and that's really trying to address the poor guys that sort of get woken up at horrible times during the day. It's actually a new area of investment for us. One of the important things is understanding cross-layering. So a cloud is made up of different layers, many different layers actually. How on earth do you visualize that? How do you look at it in real time? How do you understand dependencies of an app network? The network's dependent on other layers underneath it and physical stuff. And it's really difficult to actually sort of suddenly take a look and go, I really understand how this all fits together. Without tooling, it's frankly impossible. So spending time looking at that. The state-driven operation thing is quite an interesting use case because certainly if I look at some of the original deployments of OpenStack, where you've got Nova and things like that, Nova doesn't actually understand the state of the cloud at any one point in time. So it's not using metrics to actually make decisions. In general, it's not. I mean, I'm sure there's implementations out there, but what you get as a vanilla OpenStack component is not actually looking at metrics. So part of this use case is around how can we provide sort of some technology that says this area of the cloud is really unhealthy at this point in time, and we know that because we've just read some metrics that tell us that. How do we stop an orchestration engine trying to deploy new workloads on an area that we deem to be unfit for service? Okay, so it's really around that. It's about predictively trying to assist an orchestrator to not make mistakes in terms of where it places workloads. So lots of discussions around that piece. And obviously, areas of the cloud that are underutilized, we want to try and maximize all that sort of stuff. And you can do that by looking at the metrics of how things are actually being consumed at any one point in time. Okay, capacity planning and chargeback. So quite often, there are organizations that need to charge for the usage of the consumption of the cloud estate. Now you can do that by reservation. You can also do it by actual consumption as well. So we've looked at both, but we're giving our a lot of our customers the ability of saying, I actually want metrics. I actually want to look at specific things about what's been consumed over a period of time, not about what I reserved, and I want to charge that way. So lots of flexibility and things you can do in that space. So just how are we doing for time? Because I know you're tired and probably want to get a beer at some point, but right, we'll keep going. So in the world of software-defined networking, these are the things that you'd expect. I'm not, I said I don't want to sort of go through each of these different items. This is the capability that we can provide, everything from service chaining to gateway services, inbuilt load balancing, the ability to actually support load balancing as a service, all that sort of stuff. So, I mean, you can look at that. That's not something I wanted to dwell on. Probably this slide might be slightly more important, and that's that when I mentioned about the underlying cloud stack that you pick and choose, we're actually seeing customers do different things and in reverse orders. So, we've got now customers that effectively want a base container layer, and then they want to put OpenStack on top of that with VMs, and then their end customers are putting containers on top of that, right? And you're going, wow, this is getting more and more. When I mentioned more and more layers, that's what I'm talking about. It's sort of like, wow, and everyone's doing it upside down and all that sort of thing. What we're trying to do from an open contrail perspective is trying to not make the networking horribly complicated when our customers do that. And the aim is to effectively have a common controller layer that will actually support multiple different layers. So effectively the same controller can deal with the underlying Kubernetes layer and the OpenStack layer and Kubernetes, and obviously the extension towards Metos and wherever the end consumers of the cloud want to go with this stuff. So that's the overall objective is to try and not make sure you just have a whole load of different controllers for each one of those layers, because that just makes the world horribly difficult to really run a cloud. So it's sort of that's the rationale behind the investment. But just going back to then this whole topic of monitoring, cloud is about sharing resources. It's about getting the most out of the infrastructure you put in place. So the key thing about this is about resource contention. Where is that healthy and where it's not healthy, and what tools do you need to really understand it? How do customers make choices? What information do they have to make really say, I want this workload to be here, but what else is there, and what's running on that environment, or what's being consumed at any one point in time? They do need to make certain choices themselves. And then the provider of the cloud, whether that's an internal provider or whether it's actually an external provider, obviously is looking at, am I providing the SLA that I'm committed to keep that money coming in, right? And there's a set of visualization mechanisms you need in order to make sure you're going to be healthy, and it touches on that topic of predictive self-healing as well. You actually want to make sure the system starts to try to protect itself if something's not right, and that's really what we're seeing from our customers saying, can you help us with that type of technology? Just putting that as a picture, effectively you might have an enterprise application that consists of different component parts, obviously databases, cache, web application. Those they can be deployed anywhere across a cloud estate. Obviously, they get distributed, they get shared on the same resource, and effectively they're all sharing sort of some form of physical layer as well. Even at the CPU layer, inside a CPU, you actually have shared resources. You have shared cache memory things, and actually you can hurt a CPU quite badly with threads, depending on what you're doing, if you keep overwriting the memory. So you can create all sorts of jitter and latency problems if you're actually putting the wrong type of applications together on the same CPU. You can try doing that by pinning, but to be honest, that doesn't actually solve the problem. So there's lots of very, very low-level things that you can monitor and check to actually make sure you get the placement of applications done correctly. And generally, most people haven't focused on that yet. And obviously, exactly the same discussion around virtual network functions. They actually quite often are composite. They're made up of many different component parts, and especially as we start to create containers that are container-based technology for networking, then effectively these things are being deployed all over the place. And just trying to visualize it is just frankly impossible. You can't. So today, most people that are operating a cloud are sort of struggling, as far as I can tell anyway, based on the fact that the production environments are just getting bigger and getting more complex, and they're going through different technology selections. So it's not just one technology. You've got what you're doing in a private environment, what you're doing in a public environment, and then multiple iterations from that, and they're expected to manage it all. The fact is, these things, at any one time can be healthy, and next minute they can be unhealthy, and they've got to basically understand that. The other thing about it, though, is there's just so much data. You could collect endless amounts of data, and you can put them in a database, and then what do you do with it? And actually, a lot of monitoring systems that we've seen to date do that. They put them in a database and go, yeah, we'll do some analytics on it, but what's the end result? And we can talk about that in a minute, but it's not really helping, to be honest, the operations teams when you're doing that. So it's got to be very, very targeted analysis of metrics, and that's what we're trying to really assist with. And most of our customers say to us, there's no one place just to go and buy a cloud management system that solves all my problems. And I'm not saying that even Juniper can offer that solves all your problems. Just trying to make sure we're just a little bit better than everyone else is the objective right now. So you can buy off the shelf, well, you can buy open source stuff, right? And that's fine if you want to then go and spend your investment of time creating what is a toolkit and building the story for your operations group. But that's a never-ending cycle, and it has costs associated with it if you do that. And you end up with sort of just people have done this for a long time and it's fine, and then your core guy leaves, and then you end up with sort of the whole support problem on what is one of the most mission critical components of all your monitoring system. So it's fine, that model does work, but it's something that we're sort of saying we think we can do a bit better than that. Most legacy tools were just about collection and then doing sort of analysis on top, and that isn't what you need to do in cloud. So what do we really believe in then? These are the key three themes. It's around real-time visibility of metrics. So as soon as a metric is you can collect it, you should take a look at it and actually do analysis on it. Okay, that's the number one thing. So it's being able to read it in the first place and where do you get it from, taking a look at it and actually making a decision on what to do next, and doing that as close to real time as you possibly can. And then if you find something that you're not happy with, or there's a specific policy, actually creating a feedback loop to the orchestration engine to actually make some decisions. So that's really sort of the intent-driven cloud. So it's about real-time adjustment of what the cloud's actually doing, making decisions about potentially moving things away from each other, shutting things down, or adding things in a certain place. So it's really around sort of that, giving the orchestrator some eyes around what's actually happening on the cloud estate. I did say I'm not going to do a product pitch, and I'm not going to, so you can ignore the top part. The key thing that I'm really focusing on at the moment is this whole sort of being able to see physical infrastructure, software-defined infrastructure, the cloud infrastructure of public cloud environments, and actual a set of services that are fundamental to the cloud as well. You have to monitor all that stuff. The one thing Juniper has always been reasonably good at is physical stuff from a networking perspective. That won't surprise you. We acquired a company in December this year to really give us the IT knowledge around how to collect efficiently stuff, the attributes from a cloud environment, and combining that with the component parts we had now gives us the ability of giving all those different layers. So that's effectively sort of the framework of what we've now got in terms of the capability set, and now it's really working with our customers to make sure that we're just extending sort of the horizontal technologies that we cover. So obviously there's many other public cloud environments that our customers ask us to take a look at. How do you get statistics from a public cloud? You can do it via APIs. You can do it by a few other forms and mechanisms, but it's about getting that right. What do you get off? What do you get from OpenStack? Actually, OpenStack itself, from a controller perspective, vCenter, Kubernetes, even Contrail, all that sort of stuff, and obviously applications. They all have metrics and things about the health. So you need to get access to it all, and then it's a case of what do you do with it. So the main aim then is around a capability that suits all different types of operational roles. So everything from the guys that just do automation, NetOps. So there still will be a NetOps team. They're not going away. They'll just be part, hopefully, of a cloud organization. But there are teams that will want to look very specifically about what's happening in the network and how performant is the network. You've obviously got security operations teams. They obviously have a fundamental role in life, of course. And then your DevOps guys that are developing apps. And even in that case, there's multiple stages of what they need. When they develop an app, they actually need to be able to baseline it. So when you're actually developing things and to work in a certain way, what is it consuming when you do that in a development environment? What does it consume when you put it through test? What does it consume when you put it in production? And is that what you expected? All of that is about a life cycle, but it needs monitoring and thresholding and machine learning to do it. So this first topic really around operations analytics is actually about getting access to metrics in real time and effectively using either manually based thresholding to actually say this doesn't look right, and obviously there's nothing wrong with manual thresholds if you can work out what they should be. But it's also using machine learning technology. So if something fundamentally changes from what you'd call it as normal behavior, you'd want the system to tell you. So big spikes in usage of a metric, something goes from 20% to 90% over a certain short period of time, you actually want the ability of identifying that in the system to say this isn't normal, and therefore I want something to happen. And even if it's just an alert to an operator, that may be step one. But what we really want to do is say this is the type of problem where actually we're now going to put that specific area of the infrastructure, we're going to call it at risk. At some point, you might want to say, actually, it's now in a failure condition, just move everything away from it, based on the nature of what's actually happening. So it's about being able to sort of use machine learning to identify changes, but also define policy rules around and that enable change in the infrastructure. So giving those eyes to the orchestration piece, and that's really where you get into the state-driven orchestration. So learn of abnormalities. As soon as they happen, tell your orchestration system and actually make sure you build policies in to effectively do whatever you would do if you were manually making a change. What would you do? A lot of those things are actual repeatable sequences that you can actually program and effectively just say, next time this happens, I want the system to do it for me. And the more you do that, the easier you make your operations roll. They only deal with new problems, not old ones. So that's really what we're trying to do. Capacity planning speaks for itself. Again, I mentioned this, reservation versus what you're actually consuming. In a lot of cases, things are highly over-reserved. When you're picking your size of your VMs versus what's actually running in them, quite often when you actually look at a proper cloud estate, you've effectively completely, your reservation process isn't right. And what you might want to do is re-optimize. You might want to change the size of a VM that a component part runs on, because actually you're not consuming too much of the estate and locking everyone else out from it. So tools to actually do that sort of stuff. I guess the world of alarms have come from a networking world, so we send loads of alarms all over the place and expect somebody to understand what the hell's going on, and then we expect something else to do correlation on it, even harder. The alarms that you generate have to have a meaning. You don't just want to flood an operations team with alarms, because that really is unhelpful. And yes, they end up having to clean everything up. What you do want to do is actually identify root cause issues that you get a growing understanding as you start to deploy a cloud. Obviously, it's something that you iteratively improve on. So the key thing about this is actually defining what alarm states. An alarm can also be a notification that then gets sent to another system. It can be a pager, it can be a phone, all that sort of stuff. It really is. We're not expecting people to look at screens anymore. And when I actually talked to you, I mentioned about this, the natural language processing stuff. We're actually looking at, can we get some of these tools to actually talk to you? Like, how is my cloud cluster 1 today? The response comes back, everything's looking good, right? That sort of stuff, where it's sort of, the way that we want to interoperate with computer systems isn't just from staring at a screen. So there's many tooling things that we can actually use that are quite exciting today. Okay, so, and then reporting and billing, that's a bit obvious, I guess. All right, okay. So I just briefly talk around this. So I mentioned it, but I just want to show it visually. Just sending metrics from a compute environment, wrapping them all up from every single compute node, every single asset, which is either a database or a networking component, and shipping it to another cloud is really not very helpful. But that's what a lot of our customers do, right? And that cloud, that cluster is actually in some cases more complex than the cloud you're monitoring, and it breaks more. Right? So the general view is, why are you doing that? That doesn't make a lot of sense. But that is how most monitoring systems do actually work today. The thing is that you're sending a huge amount of metrics from your compute environment, and every single time you read it and then wrap it up, it's actually the wrapping it up and sending it that actually consumes more resource, about 2 times the amount of resource than just reading it. So you don't want to do that, really. You want to be very careful about what you ship across, what you send out. Okay, so effectively, I'll talk about that in a minute. This whole clustering thing of just sort of big databases, to be honest with you, a database has a role even in monitoring, but not for doing everything. So the aim is to minimize that. And the key thing, if you speak to most people that have that type of environment, they're not going to find anything out for at least 6 minutes anyway, because by the time that you've put it in a database, a big analytics engine's run, you're not going to get anything as a user to at least six minutes, which if you're trying to do that loop back cycle, it's too late. You've lost something in most cases. So we're trying to improve. Need a bit more real time. So this is just this is really just sort of a discussion from a technology perspective of what you can do and what we're effectively focusing our efforts on. It's about distributing policy into the cloud. So not building another big monitoring system that effectively is completely separate, because I don't see the point in doing that. What we're talking about doing is putting very, very thin agents that get deployed. So effectively, first of all, the first step is how do you deploy this thing? Well, it would be based on understanding the actual, talking to the whole Vim layer, the virtual infrastructure management layer, and saying, what is the cloud that you as a cluster manage? Understanding all that information, bringing it back as a topology, and effectively distributing very small but very clever policy components that actually get deployed on each area of compute. So putting it on the compute node. And that's a monitoring technology that effectively is looking at stuff in real time. So as soon as a metric is created, it reads it and makes a policy decision. So what we're really doing is actually creating a distributed policy for metric collection and metric analysis, where you read something pretty much as it happens and you effectively decide what to do. It might just be I'm just going to collect it and keep it locally for a period of time, and then efficiently, once I've aggregated everything, ship it off because you need it for historical information. That's fine, but it's about efficiency and filtering. In the more interesting use case, the focus is much more around, should I do something now that I've now got a reading that doesn't look right to me. So it's actually having policy that operates locally that says, I know what the normal threshold is for this metric, and the machine's basically looking at it, reading it over periods of time, whether it's daily, weekly, monthly, and actually saying this has gone way off its normal behavior. With that, you can create signals. We're using bus technology to effectively just make sure that we populate information onto a bus, which means you can have multiple consumers read it without having to continuously post it all over the place. You put it on the bus once and everything else that's subscribing to that can read it. So there's loads of technology behind sort of that type of thing, but the key thing about this is about deploying your monitoring system inside the cloud. It's looking after itself. As the cloud grows, the monitoring infrastructure grows around it, and then you get all of these other sort of tools that you can then use in terms of capacity planning, alarming, resource orchestration. Obviously, that component is a core controller that does have to sit somewhere, but again, it still runs inside the cloud, and why not? It can monitor what it's running on. It can monitor all of the OpenStack, Kubernetes environments, all the other Vim layers that you might pick, and the key thing about it is obviously that feedback loop as well. So that is sort of a whiz tour of the stuff that we're looking at the moment and the world of monitoring in terms of the principles of how this works. If you're interested at all in features, self-deploy is really important. If you make it really complicated to deploy, people get bored straight away. You can die at the lab stage, as I'm sure you guys all know, that if you spend too long, make it too complicated to deploy anything. That's a lesson we learned sort of multiple times, but with this technology, it's about effectively giving it some information, some credentials of the virtual infrastructure manager, and effectively it will just discover and deploy itself. Understanding those different topology layers is fundamentally important. So most of that information comes from what you learn. Pretty much all of it does. We even now obviously learn the network underneath as well. So understanding sort of how the network is constructed, how the virtual layers then sit on top of it, how then effectively the VMs are being deployed and connected with each other, and effectively sort of going up the stack. Cross-layering, so all the different cloud estates, and obviously all the different layers vertically as well that we just mentioned. The rest of it, I think, speaks for itself. I mean, HA, pretty fundamental to most people's lives these days. The analytics is obviously a key component of what this really is all about the ability of using different algorithms to try to identify when something doesn't look normal. So, that's all baked into the system. And a key output of that really is around the ability to predict something's about to go wrong, put it in a risk state, put it in a bad state, and let the orchestration engine make a decision. What we're not trying to do is build an orchestration engine to compete with every other orchestration engine that lives out there. We could, but I quite frankly think I'd have a whole lot of horrible meetings if that's what we try to do. We're actually trying to make sure we notify with the right information, effectively providing information with a notification that it has a context that enables the orchestration engine to make a decision. It does mean that the orchestration engines need some logic that you develop over time to actually make choices on what to do, but it is that's the automation piece that we've got to iteratively improve. So that's pretty much it. How are we doing for time? I'm really thirsty, so it must be time to sit down. I was going to do a demo, but does anybody want to see a quick demo, or do you want to see a quick thing? All right, okay. I'm glad you said yes, really. Thank you. Now, I'm just hoping I'm still on the network, otherwise it could be embarrassing. Bear with me. Where are we? There we are there. All right, so I'll start off with the a bit about the rollback stuff. So I'm going to log in as an admin. Fingers crossed. All right, in we go. So I've just logged in as an admin. I'm going to come back to that in a minute. As you would expect, that if I was perhaps an end customer, I was a tenant, you might expect me to see something a little bit less. So I'm logging into the same system. And there we go. So let me just explain that a minute. So as an admin, I want to see all the layers. We talked about that layering piece. The first thing is, how's my management doing? So this is an example of actually a cluster that's a OpenStack cluster. It'll be quite good. We're at an OpenStack event. I thought we would make it relevant. And actually looking at how healthy is the actual management system itself. And obviously you can navigate through and actually take a look at it if you want to. You can actually sort of zoom in and look at the key components either in real time or as a historical view. So this is a lab environment that hardly anybody touches, so therefore you'd expect it all to be green. Maybe in real life you will see periods of time where one of those things that you're monitoring is actually not healthy. So in the system we're building a whole load of checks, and it could just be an API call and response time, it can be pings, it can be all sorts of things that we do just to try and make sure, does this look like it's operating in normal behavior? And that's where we're saying, when we're talking about stuff coming out of the box, those are things that I think are important. That, you just basically turn this stuff on, and it's just checking the health of things because we know how to do it. We spent the time thinking about how you do it. If you wanted to know, is this particular service healthy? So let's actually go to a different cluster a minute. Hold on. So there's different clusters you can have a look at. And one thing about the GUI, I mean, this is meant to be an operations tool. So the key thing about it is, everything's green. Don't want to look at it. Not interested. Something goes red or something changes colour, obviously you propagate that all the way through the system. So in this case, this could be a massive organisation that has multiple clusters across the globe. You basically, it could even be a management GUI that you put on your big screen, the big impressive thing that says this is the cloud that we use and we consume, and this is what it currently looks like. You can navigate your way down. You can obviously start to see problems instantaneously if I wanted to if I wanted to investigate problems. I can go straight into my Europe cluster. I wanted to pick this one because it actually has a few other things in it. So hopefully in a minute. Oh, it's somebody's. Yes, it has, right. So for example, I picked this one because I just knew that there was a couple of instances where a few of them were at risk, and obviously straight away, although it's only a small set of instances that aren't right, it's telling me. I sort of want to know what they are. So I can basically just straight from here, I can say that I've got a couple of MySQL instances that basically are running rather high on memory usage. Okay, so when we're talking about monitoring parameters, so these things are the agents. They're looking at them and effectively saying, "I'm not happy with this. This doesn't look right." And it could be doing that because we actually have a manually set threshold. 90% threshold is normally manual sort of thing, but it could be actually just because it was at 20% and suddenly went to 40. That's the machine learning thing. So if you want to deploy that type of rule, it will effectively create a signal and then send it right the way through, propagate all the way through, so you can actually have a look at it. So is that first alert type? Oh, something's not right. From a discovery perspective, you can look at sort of the whole infrastructure. So everything from here when you've got virtual private cloud, these are actually instances running on AWS, for example. So that's when you're talking about the hybrid cloud environment. You look at your private, look at your public, and actually we'll bring it all together. In terms of the sorts of things we can do with this, if I look at aggregates, for example, so you've got cloud aggregates, which are the ones running on public. Let's just look at projects a minute. I'll just show you an example of some real-time stuff. So what's actually happening here, for that project, there's a whole load of different virtual machines that are all running. And what we're actually doing is aggregating the information and actually showing it, and this is a real-time view. So the agents have been told that I want to look at what's going on for a set of attributes. In this case, it's CPU usage, ingress bit rate. Don't know. You can select the whole list of what it is you want to look at any one point in time, and what effectively the agent is then populating that information as real-time as it gets it onto the bus, and we effectively as a user are consuming that. Now anybody else can do exactly the same thing. It wouldn't send it twice. It would just basically be consuming the same information. And the key thing about it is that we're actually populating for all of those different virtual machines the view on top of of these reports, which is basically saying you can see then who are the really heavy consumers of that particular metric. So a lot of this is about what tools do you need as an operator to really navigate your way down and do it in real time. So this will just keep updating all the time. And when when we start getting to the machine learning and the ability to actually make changes, is some quite good demonstrations where you can say, right, if one of my parameters hits a certain threshold, just say it's 60% CPU, I want to migrate the VM. We've got demonstrations where you can effectively see that happening. The system will send a notification to the orchestrator because it's gone over a threshold, and then you watch it just completely drop. Stuff like that. So you can all see that from a graphical perspective, and you can pick and choose which attribute you're particularly interested in. Instance memory, for example, that sort of stuff. Okay. We're near the end, and I haven't allowed you to ask any questions. I'll go through just some other pieces. Alarms, I think, speak for themselves. You can build alarms based on metrics you define, thresholds, or you can pick these different algorithms that are machine learning based. So there's k-means, there's weighted average stuff and things like that in there that just calculate changes from normal in a slightly different way. Honestly, I haven't yet learned the maths behind it. I'm not sure I'm interested, but all I know is that when something sort of spikes or something, the algorithms obviously are there to identify that type of thing. Heat maps. So one of the things that you might want to do is say, I just want to check sort of like what some CPU usage is looking like, and it just so happens that for this project, I've got one node that effectively is a bit warmer than the rest of them. So the CPU usage on that one is running at 72%. Quite often these go red and actually change colours in the real world. And there's nothing wrong with things being red. It's actually it's an adjusting threshold. So this is about what is being consumed at any one point in time, and obviously the hottest will be shown as red, amber, and then green. It's really just so you can start to see as things get more and more consumed. Then you might want to make some capacity planning decisions around it. Or if I'm looking for a specific problem that I think is out there, I can pick a metric and effectively just see what is it that where is it going to point me to as an operator. I need the system to assist me where to look, and that's what this sort of stuff's meant to be doing. Planning, so if you want to, really that's capacity planning, all sorts of charts and stuff like that. Again, you can actually look at things in real time if you want to for projects or down on hosts or whatever the scope is. And it will just update, and you can see sort of different trends and stuff like that. There's ways of actually looking at in terms of what's the overall consumption over a period of time. So when am I going to run out? All those things that you'd need to do if you're doing capacity planning. Reporting you'd expect, chargeback, that's it. And then there's a bit on, so who am I going to bill? Always a big good question. Am I going to charge sales the most because they're the most annoying people? And there's network topology stuff. So this is the bit that there's other bits of technology that Juniper was working on anyway, in terms of how do we discover networks. Not surprising that we've been looking at that. How do we actually embed that in here? And then also starting to look at how we do flow information as well. So I mean, we're just this has a roadmap behind it, but it's really about just the investment of trying to think about the poor ops guys. What do they need? So I didn't want to. I said I wasn't going to make it product pitch. That bit was, and I apologise. Sneak that in, but you did ask. So anyway, with that, I'm pretty much done. So I hope it was at least interesting in terms of what Juniper's doing. If you've got any questions, let me know. We have one.
In this app Formix, you have these charts,
yep.
And you talk about this real-time data.
Yep.
And do you have latency, or do you have? I mean, how real-time they are?
Well, yeah, as real-time as you can get it from where it originated from, how fast you can read it, and then how fast you can send it across a bus, which is a Redis bus, and then get it back to the GUI. Where there's no database in the middle. When we're doing real-time analysis on those charts, we are purposely not putting it through a database. It's effectively just reading what's been posted on the bus. Okay, I know that the GUI's built in Angular, but they have a whole load of other technology behind it, which is like gaming stuff, and it's really about performance. So what does real time mean to anybody? It means it's got to be pretty damn fast so that you can actually do something with it. So the aim is it's not minutes or anything. It's like pretty much within milliseconds, maybe seconds, depending on where the information is coming from.
Okay, thank you.
Okay, I do appreciate your time because it's late, and I'm sure somewhere there's some time for food and beer, but thank you.
Okay, thank you very much, Simon.